Imagine you have a super smart AI assistant. It can sort your emails, handle customer support tickets, you name it. It's brilliant, but it's also slow and incredibly expensive to run. And here's the really frustrating part. Every single time it sorts a support ticket, even if it's identical to one from yesterday, it has to rethink the entire problem from scratch.
It's like hiring a Michelin star chef to make you a peanut butter and jelly sandwich every single day. They'll do a brilliant job, but you're paying for all that genius and expertise every single time for the simplest, most repetitive task. It's a huge waste of money and talent.
Exactly. That's the problem tackled by a new paper from Right Now AI called Auto, the AGI Compiler. It asks a simple question. What if we could teach the AI to remember how to do the simple stuff so we only have to pay for its genius when we actually need it?
Welcome to Daily Papers, where we break down the research that's shaping our future. And today, we're talking about making AI agents not just smarter, but dramatically cheaper and more efficient.
So the core idea here is in the title, the AGI Compiler. Let's break that down. Most of us have heard of AGI, or Artificial General Intelligence, but what's a compiler?
A compiler is a classic computer science tool. Think of it as a translator. Programmers write code in a language that's easy for humans to understand, but a computer can't run that directly. A compiler translates that human-friendly code into the super-fast, super-efficient language that a computer's processor actually understands.
So you do the slow, creative work once, the compiler translates it, and then the computer can run the result a million times, instantly and for almost no cost.
Precisely. And this paper argues that today's big AI models, the ones we call frontier models, are like a program that hasn't been compiled yet. Every time you ask it a question, it's like it's interpreting your request from scratch. This is what the authors call the interpretation tax. You pay it every single time.
And Auto is their system designed to get rid of that tax. It's a tool chain that watches a big, expensive AI agent do its work, identifies the parts that are repetitive, and compiles them down into a tiny, lightning-fast program that costs next to nothing to run.
So how does it actually work? It's a really neat pipeline. First, it records. It just watches the big AI model work, handling support tickets, for example, and saves a complete log of its inputs and outputs, its thoughts, so to speak.
After it has a bunch of these recordings, it does what the paper calls a determinism census. That's a fancy way of asking how much of this work is actually predictable. If the AI is given the exact same ticket, does it give the exact same answer every time?
And what they found is fascinating. For a lot of common business tasks like classifying tickets, routing them to the right department, or extracting information, the answer is a resounding yes. They found that over 87% of the agent's actions were, in their words, witnessed deterministic. They were totally predictable.
So for that huge chunk of predictable work, Auto moves to the next step. It tries to create a small, simple program that does the exact same thing. It extracts the logic from the expensive AI's behavior and bakes it into what they call a cognition binary.
But this is the most important part, and it's what makes the system so clever. Before that little program is allowed to do anything, it has to pass through what they call the gate. This is a strict verification step. Auto replays all the real-world examples it recorded and checks if the new, cheap program gives the exact same answers as the original, expensive AI.
If it doesn't match perfectly or meet a really high bar for quality, it's thrown out. No artifact gets created. This prevents the system from shipping a cheap version that's mostly right. It has to be demonstrably correct based on past experience.
And once it passes the gate, you have this new two-tiered system. For 99% of requests, this tiny compiled program handles it in microseconds for a fraction of a penny. But what happens when a totally new, weird request comes in?
That's where the second tier comes in. The cheap program has a guard at the front door. This guard looks at the incoming request and asks, "Have I seen something like this before?" If the answer is no, it doesn't even try to answer. It de-opts, which means it de-optimizes, and kicks the request up to the original, big, expensive AI model.
And this is the magic loop, what they call the ratchet. When the big AI handles that new novel task, Auto is still watching and recording.
That new experience is then fed back into the system. The next time the compiler runs, it learns that new skill and adds it to the cheap, fast program.
So the system gets smarter over time, automatically. It pays the expensive thinking cost exactly once for each new type of problem, and then that skill becomes essentially free forever. The ratchet only clicks forward, constantly improving.
The results they show are pretty staggering. They have this one graph showing the total cost of processing 300 tasks. The standard approach, just using the big AI, is a steep, climbing red line. The cost just keeps going up.
But the blue line, which is the auto system, is totally different. There's a small jump in cost at the very beginning while it learns, and then the line goes almost completely flat. In the end, it was 6.4 times cheaper to get the exact same verified answers.
They even tested it by throwing curveballs at it. They simulated a stream of support tickets and then suddenly introduced a whole new category like security issues. You see the cost per item briefly blip up as the big AI has to handle these new, unseen tickets. But then Auto automatically recompiles, learns the new pattern, and the cost plummets right back down to almost zero.
But they're also very clear that this has to be done carefully. They ran an experiment to see what would happen with a loose guard, one that wasn't very strict about what it passed to the cheap model. The result was a disaster. The compiled system was silently wrong almost 49% of the time.
Which just proves how critical that verification gate is. It's not enough to make a cheaper version of an AI. You have to prove that it's just as good. This system is built around the idea of calibrated ignorance. It knows what it doesn't know and is honest about it.
So, what's the big takeaway here? The authors say the history of computing is a series of compilation events. We went from hand computation to stored programs to compiled binaries. They argue AI is still in that early, inefficient, interpreted phase.
And Auto is their proposal for the next step. It's a tool chain for creating the AI equivalent of a compiled program, a cheap, fast, reproducible, and auditable form of a specific skill. It's about converting expensive, fleeting cognition into permanent, near-free competence. It's a fascinating glimpse into a future where AI might not just be more powerful, but vastly more practical.